Hello, yeah, guys, greetings to all of you, right? And I really appreciate the comments that are coming out. It really tells me that, yeah, students are really benefiting from what I'm doing. And please, if you know you are benefiting from this one, please try as much as possible to share the video to those who have not yet seen it. Probably they might also understand the concept of electricity afterwards, after sharing it with them. So please do share the video. Okay, so 2 questions pop up. Okay, before we start talking about the nodal analysis, okay, today that's what we are going to talk about. I'm going to talk about nodal analysis. But before we talk about the nodal analysis, right, 2 questions pop up, right, on the Telegram page. Please try as much as possible to join the Telegram page. And when you join, you will get questions there. You see, some of the students will be posting questions and they'll be asking questions, right? Something that might be bothering you. And once you read those questions, you'll be able to learn something from it. And the journey will be so smooth for you. So try and join the Telegram page. I'll put the link in the description. If you are struggling to join, you just send me a message and I'll add you smoothly. Okay. So try as much as possible to join the Telegram page if you want to benefit fully from what I'm doing over here. Okay, so these 2 questions pop up. This is the first question. The question was asking us to find the I, this value, the I over here, and also the equivalent resistance. You did it. The equivalent resistance also. So you are finding the equivalent resistance, which is the RB. So the question says that find the total current. This is actually the total current. You are going to find the total current and the equivalent resistance, right? And the equivalent resistance is the overall resistance. That is, if I add all this resistance, that forms the equivalent resistance. So all those resistance forms the equivalent resistance. So how do you treat it? I'm just going to discuss this one, then we move on. If you've watched my Y delta video, converting from delta to Y and Y to delta, if you've watched that video, you should be able to do this to reduce the circuit. So how do you do this thing? How do you solve questions like this? You need to always this is a delta connection. The 10 ohm resistance is not in series or parallel to the 50 ohms. So it is not. Take note, some students might see it to be series, not series, right? That is, I'm talking about the 10 ohm resistance and and the 50 ohm resistance. They are not in series. Neither are they in Neither are they in parallel. Why? Because I made it clear that this resistor over here is causing is connected between them, which makes it difficult to know whether they are in series or parallel. So this one, we have 2 delta connections. So we have 2 delta connections here. We have the first one to be the 40, that's the 24, and and the 10, right, and the 20. It's a delta connected circuit. Or I can also choose to say that the 30 ohms, the 50 ohms, right, and the 20 ohms, they are also in delta connection. So please, if you've not watched my Y delta conversion video, please watch that one. If you watch that one very well, you should be able to solve this question. It should be at ease for you, right? But I'm just recapping that one with this question. You get it. So what we do is that we convert. You can choose any of them. I can choose the downside or I can choose the top side, right? I can convert the top side to a star, something like this. Then this one here, and I have a resistor here. You get it? So I have RA, RB, and RC. You get it? You stick to only one. So you can choose the top there, you can convert what is up there, or you can convert what is down there. Okay. Any of the two, you should get it correct. Here, I'm not going to solve all the questions, right? I'm just going to explain things to you so that you solve it. After solving it, you can send the images of what you solved to me, right? Personally, I'll put my contact in the description. So you can send it to me to see whether you are right. Okay. So you convert one of them, either the down there. I didn't choose the down there. I choose upward, right? So I can choose to convert this one to what? A star, right? And after converting it, right? After converting it, this resistor will go off. This resistor will go off. And this resistor will go off after the conversion. So what will be my new circuit? My new circuit will be something like this. I'm going to get like plus here, minus, right? The voltage there. And I have my I here. You get it? And I have my resistor 13 ohms. Then I'll get my what? My star connected circuit. Right. Yeah, very good. Then I'll get my 30 ohm resistor down here. Right. Then another 50 ohm resistor here. And it will combine with this. Very good. So this is how the circuit is going to be now. 30 ohms, 50 ohms, right? So now after solving my RA will be here, the RC will be here, and the RB is going to be here. You get it? Now what do we see here? We can see that, we can clearly see that these two resistors, okay, let me change the color. The yellow is not other color. Let me use blue. These two resistors, they are in series. Right. These two resistors are also in series. You get it? And these two resistors, they are also in series. Very good. So now we can reduce the circuits. Right. Now let's reduce the circuits. I have, let me write the values of the voltage, right? The voltage has still not changed. That's 100 volts. Then I have my I flowing, right? I flowing. Okay, very good. So now, what do we have again? I can now do what? Reduce the two circuits up there, the resistance, right? So this is how it's going to be. I have my 100 volts here, still 100 volts. Then I have my I here, right, which has still not changed. Now I have a very big resistor at this end, which is going to be 13 plus what? RA. They are in series. Do you get it? Yes. So I also have another resistor here, which is going to be what? 30 plus RB, right? Then there will be another resistor here, which is going to be what? 50 plus RC. So now this is what I get. Something like this. You get it? So we are still reducing the resistors. We are still reducing the resistors. So what do I have now? Now I can see that these two resistors, right, they are connected in parallel. So how do you do it? The new circuit is going to be something like this. So plus here, minus here, right? Then I have a resistance here, which is what? 13 plus RA. That's the value of the resistance that we find during the delta connection. Then I'll have a big circuit here like this. Break resistance, sorry. The break resistance here like this. It is going to be what? 30 plus RB multiplied by what? 50 plus RC, all divided by what? 30 plus RB plus 50 plus RC. Since they are in power connection, right? You know that if two resistors are in power, the formula is R1, R2, all on what? R1 plus R2. You get it? So that is how we obtain this one. You get it? So now, we can now combine these resistors in series. And combine the two of them in series to get our RAB. That is the RAB, which the question is asking us to find, can be equal to what? The 30 plus RB multiplied by what? 50 plus RC, all on what? 30 plus RB plus 50 plus RC, all plus what? We are in series, so 13 plus RA. Please, if you are confused with this, if you are confused with what I'm doing here, it's because you don't understand the conversion from what? Y to delta, or let's see, delta to Y, or vice versa, or delta to Y, or delta to Y. You don't understand this, and I've made a video on it. It's about an hour video, and I took my time in explaining it. So please watch that video before watching this one if you want to understand a question like this. You get it? So now that we found our RAB, the current is going to be simple. You know that V equal to what? IR. So once V is equal to IR, we can say that I equal to what? V on what? On R. So I is going to be what? The 100 volts all over the solution to what? This one. That is RAB. Are you okay? That will help you to solve this question. So please try as much as possible to watch that video and solve a question like this. Okay, so let's continue with the second question. Are you okay? What is the second question stating? The second question, right, is saying that we should what? We should find the voltage, right, across the 10 ohm in the figure below. We are finding the voltage across the 10 ohm resistance. You get it? Yes. So how do you do it? It's very simple as well. There are so many ways of doing it, but I'm going to show you the simplest way, right? First of all, find the current flowing through this resistor. Once I'm able to find the current flowing through this resistor, I can multiply it with what? The voltage. That is V equal to what? I multiply by what? 10. To get the voltage in the 10 ohm resistor. And how do I find the current here? I'm going to apply the source transformation. And let me write the source transformation. Oh, sorry. I'm going to apply the source transformation and current division. That's the easiest way to get the solution to this. You can also apply source transformation and mesh, but we are going to spend longer time. But the shortest way to do it is to apply our source transformation and current division. So please, if you've not watched that video too, try as much as possible to watch it. Watch the videos, understand the concept. If you don't understand anything, just send me an information, right? And I'll respond to you as quickly as possible. So how do you do this? I'm going to convert this one to what? To a current source, which is what? Parallel to a resistor. So I'm going to convert these two sources. And how do I do that? Let's see. So the new circuit is going to be something like this. I have my 3 amps here, right? Then I have my 10 ohm resistor. Please take note. When they ask you to find the current at a branch, right? Don't change the stature of that branch. Don't add the branch to any other, like let's say, branch. Like what we are doing here. See, we have two branches here, and I'm going to change their position. As soon as I change it, the current value changes. Right? So don't touch the resistor where they've asked you to find the current. If let's say you are doing any conversion to the circuit, as soon as you do that, you are not going to get the exact value. Okay. So with this one, like I said, I'm not going to touch the 10 ohm resistor. So let me just use the right in there to show that I didn't make any changes to the 10 ohm resistor. So we have the 10 ohm resistor here. I've not made any changes to it. Right. So with this, I have the resistor here, and I'm going to do the conversion. So here I will have, let's say, a 20 ohm resistor, right, which will be what? Which is parallel to what? A current source.
Yes, I'm with you.
Which is parallel to the current source, right? And the current source is what? It's going to be upward because this voltage is moving upward, right? So it's going to be, you know that V equal to what? IR, and I will be equal to what? V on R. So here the current source is going to be the voltage, which is 12 volts on what? Sorry, not 20. It's going to be 12 volts on what? On the 20. That's the resistance. You get it? If you've not watched my source transformation video, try as much as possible to watch it, and you understand what I'm doing here. And we also have 40 volts here, right? 40 ohms, sorry. So 40 ohms, which will also be parallel to what? To a current moving upward. And this current is going to be what? 16 on 40. Right? Watch my source transformation video and you understand what I'm doing here. We have three currents. Let me label them as, let's say, I1, I2, and what? I3. So these three currents, I can combine all of them. Since they are all moving upward, right? I'm going to add them. Let's say the IT is going to be what? 3 plus 12 on what? On 20 plus 16 on 40. They are all moving upward. So the total current is going to be adding all of them. If one was moving upward, downwards, right? That one would have been subtraction. Now this one, they are all moving upward. So we are going to add all of them. Okay. So with this, I can say that I'll get, let's say, 120 on 40. I just find the equivalent fraction of 3, right? Plus 24 on what? On 40 plus 16 on 40. So since they are all equivalent fraction, I can add the numerators. Right. So here 3 on 40, let's say 3 is the same as what? 120 on 40. I just found the equivalent fraction. And the equivalent fraction of 12 on 20 is what? Is by multiplying the up there by 2 and multiplying this one 2 by 2. Here 2, I multiply here by 40 and divide by 40. So I've done nothing to it, but just finding the equivalent fraction. So with this, if I should add the 2, 6 plus what? 4 is 10 plus 0. And we are going to get what? 0. Right? 120, 24, and 16. So this is going to be 0, remember 1, and add it to it. I'm going to get 50, 60. Right? So 6, then 1 here. So it's going to be basically 160 on what? On 40. Right? And this is going to give me 4 amps. So the total current is more like 4 amps. Right? Let me write the 4 amps somewhere here. So IT equal to what? 4 amps. Then let me wipe the board nicely. What do I do again? What's the next thing that I need to do? I need to what? Find Okay, sorry. I need to find the what? I need to find the total resistance for these two. Right. I can combine these two resistors. And how do I do that? This resistance, these two, because they are in parallel. See, there is no resistor on this path. So these two resistors are in parallel connection. Let me change the marker. So these two resistors, this one and this resistor, they are in parallel connection because there is no resistor that is cutting across them, right? All this path, there is no resistor here. So the two of them are in what? Are in parallel connection. So there are 20 ohms, 40 ohms resistance. It's going to be what? 20 times 40. All on what? On 20 plus 40. And this is going to give us 800 on what? On 60. Right. So 800 on 60. And this is what we get. So let's simplify it and see what we get. You get it. So 80 divided by what? 6. I'm going to get 40 on 3. So you are going to get 40 on 3. So that's the total resistance. You get it? Yes. So the new circuit, what the new circuit going to be? I'm going to get a current source, which is what? 3 amps, right? Then I will have my, no, not 3 amps, sorry, the IT. We had 4 amps. All the current sources, we are combining all the current sources together. So it's going to be what? 4 amps. 4 amps here, right? Then I will have my, how do you call it? My 10 ohm resistor over here. I've not changed it. Not changed anything. Another 10 ohm resistor. So I have my 10 ohm resistor here, right? And attached to it is the what? Is the resistor that we combine, the two resistors, right? Which is equivalent to what? 40 on 3, right? But our target is to find, how do you call it? Our target is to find the current flowing through what? The 10 ohm resistor. So I. That was our target. We said we want to find I here. And after finding I, you just multiply with the voltage, the resistance, to get the voltage over there. So here, if I want to find it, right, the I is simply going to be what? The opposite resistance, which is 40 on what? On 3, divided by what? The sum of the resistance, which is what? 10 plus 40 on what? On 3. All multiplied by what? The total current, which is what? 4. 2 times 4, right? And if I should compute this, what do I get? I'm going to get, let me see, 40 on 3, all divided by 10 plus 40 on 3, bracket close, times what? Times 4. So at the end, I'm going to get the I to be what? 2.28 or 2.29 amps. Right. So this is going to be the current value. So to find the voltage at the 10 ohm resistor, all that I need to do is to multiply the current with what? With the 10 ohm resistor. That is very equal to what? IR. So at the end, what do I get? I'm going to get 2.29 all multiplied by what? By 10. And this should basically give me 22.9 volts. So that is the voltage drop at the 10 ohm resistor. There are so many ways of doing it, but this is the simplest way. Are you okay? This is the simplest way that you can ever get. So You can solve this one. You can try other ones too, and you need to get it right. You can apply mesh. How do you apply mesh? You can apply mesh and source transformation. Convert this resistor to what? To a voltage and let's say a resistor in series, so that you get a circuit to be something like this. The circuit will be something like this. No, I'll not encourage you to use the mesh. The reason why I'm not encouraging you to use the mesh is because, see, we are working on this resistor. So if you are working on it, don't touch it in the circuit. Do not touch it. Don't touch it. But you see, one interesting thing is that you can use nodal analysis in solving this question. You can apply nodal analysis. So you are going to learn the nodal analysis here today. Today you are going to learn the nodal analysis. And once we learn it, we pick up this question again and apply nodal analysis in what? In solving it. IoT. So we are going to solve this question again with nodal analysis to find the voltage in the 10 ohm resistance. IoT. Are you good to go? Yes. So that's the question that we are going to solve under nodal analysis. Okay. So without wasting much time, right? Let's start what we're about to do today. I've addressed the two questions. If you have any question, just place it in the Telegram page, right? Place it on the Telegram page, and I'll address it when I start a new video. Anytime I'm starting a new video, I'll address those questions. So these were the two questions I received yesterday, and I saw the need to address it. So I've addressed them, and I believe those who asked it will benefit from it, as well as those who are yet to see the question. So let's continue. We are going to start our tutorials with what? Nodal analysis. And this is the easiest of all the complex circuit analysis that you can get. The nodal analysis is the easiest, right? On nodal analysis, you can get, you see, we talk about paths. Please, this is not the time to explain paths again. So we say path is what? The distance between two principal nodes. In our video, we said path is the distance, right, between two principal nodes. Someone will say, what is principal node? Please watch my video on the fundamental circuit analysis. The fundamental. I talk about all this during the fundamental video. So if you are struggling to understand path and principal nodes, please watch the video. IoT. So we are going to apply that one here. So I can get a principal node here, right? Let's say two principal nodes. And I'll get a path with only what? A resistor. I can get a path with only a resistor, right? Let me call it RE. Right? And I have the current, let's see, the current that is flowing through it is I1. RE. I can also get a path with what? With a resistor and what? And a voltage source. Plus, minus. Right? I can get a path like this. So, with the current, let's say the current is flowing what? Downwards. Let me do the current flowing downwards. Right? And let me call it I2. And let me call this one VA. Right? Then I have RA. I can get a path like this. I can also get a path with only current source, RT, with a current value. Let's say a path with a current value, right? Yes. Let me call this. Let's say IA. That's all. So I can get a path like this in a circuit. You get it? Some will be a path with. So once I get the path right, the two principal nodes, I call one of them as, let's say, node VIII, and this one should be what? VIII. Right? This is VIII, VIII, the principal node. Right? At that point, there is always a voltage, and those voltage can be called what? VIII and what? VIII. Between two principal nodes, there is a voltage value. When the node is considered as a reference node, you can have a reference node. Let me draw another one. Right? Another one, like let's say I have a resistor here. Then only a resistor is connected to what? A reference node. Normally, this is what you have. You have VIII. I'm considering VIII as a reference node. And let me call this R1 and VIII. Okay. I can equally get a node to a reference node, right? And this time it is a voltage source. What did I do for this one? I made it plus and minus IoT. Let me treat this one to be what? Minus and plus to a reference node. That is VIII. Then I have the current. The current is almost the same. VIII to a reference node. Let me see. Sorry, I have a current source here. So the current source moving upward, right? Let's say IoT. So here the current is moving downwards. Let me show the same idea here. The current is moving downwards, I2, and here too the current is moving upward, I1. Right? These are the possible paths that you can get during nodal analysis, and all these ones, right, can be found in the circuit that you will solve. So they are all there here. So let's see. I have a possible path here which has, so you see all this one is a node. I can consider all this one as one node. I think let's put this one aside and we'll get back to it. So what do we do? Please pay attention. Here is so critical. So if I get a path like this, right, and I want to find the current value here, we know that I is equal to what? V on R. We all agree from Ohm's law. So if I want to find the current here, I need to find the ratio of the voltages, right, on the path to what? To the resistance. That's the ratio of the voltage over the resistance. The ratio of the voltage to the resistance. So for instance, if I want to find I1 here, let's take note. I need to know where the current is starting from. Where the current is starting from. This current, the I1, it is starting from V2. Right? Starting from V2 all the way moving towards V1. So I'll start with the V2. V2 minus the V1. That's I subtract the nodes. But where it is starting from becomes the starting point. That is it's starting from V2. It's going to be V2 minus the V1. I find the difference of the voltage at the nodes. And aside that, there's no voltage supply here again. There's no voltage supply. So in that case, I'm going to divide it with the resistance. How many resistance do you have here? I have only one resistor. So it's going to be what? RA. Someone might ask, if let's say I have two resistors there, right? They'll be in series. Let's say I have RB here. So in that case, what do I get? I'm going to get plus RB. You get it? Please reverse the video again. If let's say you are struggling, reverse the video and understand the concept here. How to find the current on that path. Are you okay? Yes. So if there are about 3 resistors here, I just add the resistors. You get it? So for instance, I'm going to write it for this one again. If I want to find the I1, it's simply going to be what? The starting point, which is V2 minus the ending point, right? Minus V1, all on what? on the sum of resistors on this path. At this point, I have two resistors, RA and RB. So I'm going to get RA plus RB. And that is going to be what? The current that is flowing through that path. Do you get it? Yes, very good. So let's move to this one too. This circuit, right? So to find the current I2, how do you find it? The starting point is V1 and it's moving all the way to what? V2. So with this one, I'm going to get what? V1, right, minus V2. Yes, so the ending point is minus V2. At this time, there's a voltage source here. And we need to add the voltage source to what? The voltages at the terminal. And how do you do that? We just imagine, or we just look for the conventional flow of this voltage. See, what's the conventional flow? The conventional flow is moving what? Upward. Right? Yes. So since the conventional flow is moving upward, we ask ourselves, if this voltage is to generate what? Current. Will it oppose the I2 or it will be in direction with the I2? Okay, so since it is opposing the I2, it is opposing it. So I2 is moving this way and the current generated by the voltage is moving upward. So they are opposing, and since they are opposing, I'll make it what? Minus. If they are in the same line, it's going to be plus. If they are opposing, it's going to be what? Minus. So minus what? Minus VA, all divided by what? The total resistance on that path. You get it? All divided by the total resistance on that path. So this one is opposing it. This the main. I'll find the ratio of the resistance towards to the ratio of the voltage to the resistance. When you are starting, it's going to be what? V1 is starting from V1. So the I2 is starting from V1. So give me V1 minus V2. Then I ask myself, the voltage here, if it's supposed to produce current, is it going to oppose the I2 or is it going to be in phase with the I2? Since it is opposing the I2, right, we are going to use minus here. If it was in line, we use plus. You will see that in the diagram below. So since it's opposing it, we are going to use minus what? VA, right? Then we get our I2 value. You see, with nodal analysis, our target is to find the current on the path and use the ratio of voltage to resistance. You get to understand it better as you move on. If let's say I have the current source, that one, I just maintain it like that. My target is to find the current value. So once I have a current value there, there's no need to look for any other voltage to resistor ratio. Okay. So if you have a current value, I just maintain the current value. So let's move on to the next one. Right. Reference node is always equal to what? 0. Reference node is always equal to what? 0. Right. That's reference node. Ranging will always be 0. So you always pick one point as a reference node. And it's always going to be what? 0. Okay. So at this point, if I want to find I1, right, the starting point is what? Vg. It's going to be what? Vg minus the ending point, which is what? Which is V1, right? All divided by the total resistance R1. And Vj is equal to 0. So I1 is equal to what? 0 minus V1 on what? On R1. And that gives negative V1 on what? R1. So that's the current that is flowing there. The difference between these two, the difference between the first one and the second one here is just the reference node. They are the same, but just that the reference node makes it different. So let's look at this one too. Let's look at this. So if I want to find the I2 current, right? The I2 current is basically going to be what? the starting point, which is V1, right, minus the ending point, minus Vg, right, all on what? The total resistance. Let me call this Rb, right, all divided by, no, we've made one mistake. Why? We didn't add the V what? The V, let me call it Vb. We didn't add the Vb. So let's go back and add the Vb. Let's start again. Okay. So with this one, let me start the analysis again. So I2, what is going to be I2? I2 is going to be what? The starting point, which is what? V1, right? Minus the ending point, Vg. Now we want to add the Vb to it. Assuming this Vb is producing current, it's going to what? Be in line with I2. Like I said, if they are in line with I2, we just do what? We add them. I2. But if it's opposing, we do what? We subtract. So at that point, it's going to be what? Plus, how do you call it? Plus Vb, right? All on what? On the resistance, which is Rb. IoT, and that gives us the value. And what about the last one, which is the IT? That one, the current is already there, so we just maintain the current. Do you get it? Yes, we maintain the current to get our answer. Okay. So now that we've been able to identify the paths of, let's say, all the possible paths that we can get when we are analyzing nodal analysis, right? Let's now focus on the question. So we are going to focus on the question now. So this was the question the student brought, and we've already solved it using the, how do you call it? We use the source transformation and current division. So source transformation and current division. We use that one in solving it, but we want to use the nodal analysis in solving this one. IoT. We want to use the nodal analysis in solving it. So first of all, before you can apply the nodal analysis, you need to first identify all the principal nodes. Right. First identify all the principal nodes in the circuit. So what are the principal nodes here? If you are struggling to identify principal node, please try to watch my fundamental video. I explain the principal node there. So with this one, we have the first, all this one, right? Because there's no element here, you can combine all this as one, right? And we will see it as one node. And all this side too can be considered as another node. You get it? Yes. So we have two principal nodes in this circuit. So one of them can be considered as a reference point, which is termed as the VIII equal to 0. Right? One of them is always considered as the reference point. So the reference point is seen to be 0. And the other node can be considered as V1. You get it? So at a point, I can put V1 here, V1 there. All of them are the same. So for instance, let me just clean this. Let me clean all these ones. So if I'm considering it, let me use the control plus C instead of doing it. So I've explained that one to you, right? So at this point, I'll consider this as what? V1, right? And it's the same thing over here too. That notes, they are the same. There's no element there. So V1, it's the same thing. So all this one, like I said, is 1. And this side too is what? Ground and ground. They are all 0. V equal to 0. V equal to 0. Because there is no element at the top here, neither is there any elements down here. So we can consider this one as ground. Which is VG and VG. Right? And it's equal to what? 0. 0. In some books, you will find V0 is the same thing. V0 equal to what? Vg. There's no difference. Are you okay? So with this one, you see, with this path, on this path, the path from here all the way to this side is having a current source, so we ignore it. But we show a current direction at this point. With this, you can show the current direction upward or downwards. It depends on you. But you just need to make sure that, like what we said when we were talking about the KCL, all the current source shouldn't get towards one node. At least some should be entering and some should be leaving. So I can show this current direction downward like this. Whilst I show this one, let's say upward. I can show this upward and this direction towards the VIII. Do you get it? And with this, I can label it as I1, I2, I3. See, this circuit, right? The circuit that you see here can be drawn like this. I have my VIII here, right? And I have, let's say, the current source, which is moving upward, right? The 3 amps. And it's moved all the way towards the ground source, which is the Vg, right, equal to 0. Then I also have the I3 path this way. I have my 10 ohm resistor on that path. So 10 ohm. And the current is moving downwards. That is I3, right? Then I have the VIII resistance, which is this way. I have the resistance here. Then I have the voltage source, right, which is plus and minus IOT, and it's getting to the VG there. Right. I have my 12 volts here, and I have my 20 ohms on this path. Then the last path that we see there is the 40, right, 40 ohms with what? A voltage source, which is plus minus IOT. So at this point, you have something like this, 16 volts IOT. So this is the equivalent circuit. I've done nothing. I've just taken off all the wires, all these wires. There's no element there. So I can combine all of them as one point, one node. And all these two can be combined as another node. So the top there can be seen as one node. The down there too can be seen as one node. IOT. And the top node, we call it as what? VIII. Always, one of the node is a reference node. You get it? So one of the node is a reference node and it's equal to 0. IOT. Since we have two nodes, right? We need one equation in finding VIII. IOT. If I have 3 principal nodes, I need 2 equations. You get it? So it normally comes in the objectives that in nodal analysis, if I have 3 principal nodes, right, how many equations do I need to find the voltages at the node? It's a typical question in the objectives, right? So for instance, if let's say I have 2 equations, if I have 2 principal nodes, how many equations do I need in solving in determining the voltages at the node? I need 1 equation. So the number of equations that I need is always n minus 1. Right? The number of equations that I need is always n minus 1. This question do come in the objectives. If let's say you are solving objective question, it do come that if let's say I have 3 principal nodes, how many equations do I need to determine the number of the voltages at each node, right? And if I have 3 principal nodes, I'll always need 2 equations. If I have 4 principal nodes, I'll need 3 equations. If I have 5 principal nodes, I'll need what? 4 equations. So this is how it looks like. I have my I 3 here, and I'll have my I2 moving upwards. Sorry, I2 is moving upwards. Then I'll have my what? My I1 also moving towards the direction of VIII. Okay, so we can see that it obeys the condition for what? KCL. Some of the currents are entering that node, whilst others are also leaving the node. Okay, so now I can write KCL equation for the circuits. Right, I have the 3 amps. The sum of current entering equal to sum of current leaving. So the 3 amps is entering. So 3 plus I2. I2 is also entering. Plus what? Plus I1 equals what? I3. So it's only I3 which is leaving. So 3 amps is entering. 2 is also entering. Then I1 is also entering. So the sum of current entering equal to what? The sum of current leaving. Now let's see what to be I1. We previously did this. Let's find I2 first. So I2, this is the path. This is the path of I2. So it's starting from what? The ground point, which is what? VG. Right? That's where it's starting from. And it's ending at where? V1. So minus V1. Okay. There's a voltage source there. And if the voltage is supposed to generate what? Current. Right? It will be moving what? Upward. Which is in line with I2. So in that case, I'm going to do what? I'm going to add plus what? Plus 12. Okay. All on what? All on, how do you call it? All on the 20 ohms. Okay. So in this case, if I simplify, the Vj is 0. So 0 minus V1 plus 12 all on what? On 20. So what to be I1? I1 is simply going to be what? 12 minus V1 on 20. Do you get the concept? Yes. If you don't get the concept, please reverse the video, and I believe that you are going to understand it. I've taken my time to explain how to write the current equation for each path, each possible path. Okay. So what about, let's try the path for I3. This I3, this is the path. So it's starting from what? V1. It's going to be V1. Then we move to what? Minus Vg. Since there's no voltage source there, I think the voltage difference is okay. So it's V1 minus Vg. All on what? On the resistor there, which is what? 10 ohms. So at the end, we are going to get V1 minus 0 all on what? On 10. And this gives what? V1 on 10. Do you get it? Yes. What about I1? I1, as you can see, is starting from what? Vg. Right? So Vg, and it ends at V1 minus V1. Okay. We have a voltage source on the path. So if this is supposed to produce current, right, it is equally also going to move in the direction of what? In the direction of the I1. So it means you are going to do what? You are going to add 16 to it, which is going to be what? Plus 16. Okay. All on, what's the value of the resistor there? 40. And this should give us 0 minus V1 plus 16 all on what? On 40. And this equal to what? 16 minus V1 on 40. See, when you are solving the question in the example, right, you can skip some steps. Some steps are not relevant. It's because I'm teaching. That's why I'm bringing the steps so that you understand it very well. But some steps are not relevant when it comes to the exam score. Like for instance, this one like this is good. You need to bring this one. But we see with this one, I can skip this step and just simplify it straight away to be what? 60 minus V1 on 40. Are you okay? So let's continue. So now that I've got my I1, I2, and I3, this equation 1, I'll substitute the values into equation 1. So if I substitute the values into equation 1, what do I get? I'm going to get 3 plus, what is I2? I2 was given as what? 12 minus V1 on what? On 20. Then what about, how do you call it? Plus what? Plus I1, right? And what's I1? I1 is 16 minus V1 on what? On 40, right? And this will be equal to what? The I3, which was given as what? V1 on 10. Very good. So now, to find V1, you just solve this equation. So how do you solve it? You are going to get 3 plus 12 on 20 minus V1 on what? On 20 plus 16 on 40 minus V1 on what? On 40 equal to V1 on 10. I've just separated the fraction here. Right? This is mathematics. So at the end, what do I get? I'm going to group like that. So I have 3 plus 12 on 20, right? Plus 16 on what? On 40 equal to V1 on 10. I'm carrying this one to that side and this one equally to this side of the equation. It's going to be plus V1 on what? On 20 and plus V1 on 40, right? Yes, so what do I get again? If I further simplify this one, right? So let me use the calculator straight away. So it's going to be 3 plus, so 3 plus, how do you call it? 12 on 3 plus, sorry, 3 plus 12 on what? On 20 plus 16 on 40. And that should give me, sorry, 16 on 40. Okay. So 3 on 20, 16 on 40. All this, if I sum them up, I'm going to get what? 4. 4 equals to. Then what about this one? 1 on 10. 1 on 10 plus 1 on 20. Plus 1 on 20 plus 1 on 40, right? So 1 on 40. And that one should give me 7 on 40. If I simplify it, I'm going to get 7 on 40 V1. You get it? So basically, V1 is going to be what? 4 times 40 on 7. That is, if I should, how do you call it? If I should multiply this side by what? 40 on 7 and multiply this side by 40 on 7, right? The 7 cancels the 7, 40 cancels 40. So I'm going to get 40 times 7 all on 40 times 4 all on 7. Then you equate it to what? V1. So at the end, what do we get? V1 should be equal to what? 160 on 7. What's the final answer for that one? So 160 divided by 7 should be equal to what? 22 point what? 0.9 volts, which is the same as the answer that we had initially when we were solving it with the source transformation and current division. That was the answer that we had, right? Yes. See, the good news is that the voltage on the node, right, is the same as the voltage for the components, all the components on that part. So you see, this one like this, the voltage here is going to be 22.9. Okay. The total voltage on this path should also be equal to the 22.9. The total voltage on this path should be equal to what? 22.9. And the total voltage on this path is equal to what? 22.9. So if you are given the question like this, don't worry yourself saying that the voltage is what? 22.9. Okay. So let me find the current there. Then I multiply the resistance. It's waste of time. If I have only one component on that path, then the voltage drop in that component is the same as the voltage of that node, its node. Okay. So with this one, I don't need to find the current. Okay. But you can go ahead and still let's do it and see. That one is more like pathology, right? Let's do it and see. I want to find the I1, right? The current that is flowing through that path. I3, right? So to find I3, what was the value for I3? I3 was given as what? V1 on 10. You get it? So I will get V1 on 10 as I3. That was the value that we had when we substituted. So I3 was equal to what? V1 on 10. So in that case, what do I get? I'm going to get the 160 on what? On 7, all on what? On 10. And this gives me what? 160 on 70, which is 16 on 7. I3. But how do I find the voltage there? V10 ohms. What do I do? I just need to what? Multiply the I3 by what? By the resistance there, which is 10 ohms. And that one gives what? 16 on 7 times 10. And this ends up becoming the same 160 on 7, which is over here. Okay. So the truth is that if let's say I have a node over here, right, and between that node there is components there, so the overall voltage drop on that path is equal to the voltage drop of all the components on that path. Okay. So here like this, the voltage drop for the 10 ohm resistor is just the voltage drop over here. Okay. You get it? Yes. So we'll talk about another question another time. Time is fast spent. And I believe you had the concept on node analysis. Please, if you are still struggling, reverse the video and watch again. You get it? You have the video at your convenience. Anything that you want to do, you can do with the video. You can reverse it. You can watch it over and over and over again till you understand it very well. You get it? So that's all for the day. That's all for the day. If you come across any node analysis question and you are struggling to solve, or if you come across any circuit which you want to use nodal analysis or you are struggling to solve, just drop it on the page, on the Telegram page. I'll put the link in the description. Join the Telegram page and post your questions there, and I'll address it like how I addressed these circuits, right, when I was talking about the nodal analysis. I'll also solve some questions when I'm making the next video. Like, let's say if the next video is going to be on superposition. So when I'm talking about the superposition, I'll solve a nodal analysis question again for you to see. So please just subscribe to my channel. Subscribe to my channel. I can see more people are viewing it, but few people are subscribing. So subscribe to the channel so that you will be able to see the new videos that I upload. After subscribing, please click on the notification bell icon. So I wish you all the best, and I wish you a successful semester. Please try as much as possible to get 80 or above in applied electricity to boost your CWA. So I wish you all the best, and I'll see you in the other videos. Goodbye.